taking a look at our first word problem, and we are going to apply algebra, and we're going to use an equation to find out what a unit of measure represents. And in this example, we're looking at Reverend Martin Luther King, and in 1963, he referenced a speech by Abraham Lincoln. So let's take a look. Read for understanding in this problem starts off with, in 1963, Dr. Martin Luther King began his famous "I Have a Dream" speech with the words, 50 years ago. Well, I don't really know what a score is yet, and yet you could Google it, or we can write an equation and figure it out. Guess what we're going to do? We're going to write an equation. And we're talking about signing the Emancipation Proclamation in this particular problem, and it tells us the Emancipation Proclamation was signed in 1863. Well, Dr. Martin Luther King is talking today, and it is 1963, and that's when he said 50 years ago. Well, how many years is it from 1963 to 1863? Hopefully you guys are doing a little bit of math in your head, and you discover that is equal to 100 years worth of time. And if I read this speech, it says, I have a dream 50 years ago. Well, that was this many years ago. So 50 must be equal to 100 years. And if I look further, it says, let S represent the quantity in years of a score. So instead of writing 50, we're just going to write 5S equals 100 years. We would like to figure out how many years are in a score. Well, this only has one step. We see 5 times S, and we're going to apply the division property of equality. We'll divide both sides by 5, and that'll tell me an S equals 20. Now, because it's a word problem, let's answer the question. How long is a score? Well, a score is 20 years. And that is how you use an equation to define a unit. Okay, let's take a look at example 2 about defining a variable. It says an airplane descends in altitude from 20,000 feet to 10,000 feet. So descends means to drop. So if I make a very poor attempt at drawing an airplane, and there it is, and then we're going to have that airplane drop, and it drops from 20,000 feet all the way down to, let's see if I can draw that same poor airplane again. Oh, it's just wonderful. Down to 10,000 feet. Let's take a look. How many feet did it drop? It went from 20,000 down to 10,000. Hopefully you guys can do some simple math in your head and you realize it just dropped a negative 10,000 feet, right? Let's take a look at the radar traffic control. They actually have a gauge, and it reads that the airplane's altitude dropped by 1.8939 miles. So even though the airplane actually dropped from 20,000 feet down to 10,000 feet, the radar traffic control doesn't have feet, they have miles. And they let us know a little bit more information. They said, let M represent the quantity in feet of a mile. The real question is, how many feet are in a mile? And that is M. Well, we know we dropped 10,000 feet, so I'm going to go ahead and put 10,000 feet there. The question is just how many feet are in a mile. If I wanted to talk about dropping 10,000 feet, I would put a negative sign there. But since I just want to know how many feet are in 1 mile, I don't think I need the negative sign. The radar at the traffic control read 1.8939 miles. 1.8939 times however many feet are in a mile must be the same as 10,000 feet. So if it was 1.8939 miles times whatever is there. So in order to solve this variable, solve the equation, isolate the variable, we're going to divide here. We're going to divide by 1.8939 on both sides. And you know what? I don't know about you, but I don't really feel like doing long division. I'm going to use the calculator. We're going to take that 10,000 and we're going to divide it by, and it's going to write it as a fraction. It's just going to look like our equation, 1.8939. And as long as you always want to check and make sure you punched it in correctly, and you'll see that it tells us, there's our answer right there. And we're not going to get into the decimals, but what we now know is there are 5,280 feet in 1 mile. Thanks to our equation. Let's take a look at a couple of these problems. I don't want to solve them for you, but I do want to help you read through, talk yourself through, and try and set them up in a way that will allow you to get to the answer. Let's take a look at this first one. You bought a magazine for $5 and 4 erasers. So I bought a magazine and I bought 4 erasers. And if I write that out, I bought a magazine plus I bought 4 erasers. And I'm just going to write it like that for now. And it says I spent a total. Well, that means equals. When I buy a magazine and 4 erasers, I spent a total of $25. Well, I know that I bought the magazine for $5, so I'm not going to write M. I know what it cost. I know it cost $5. And I bought 4 erasers and I spent $25. And now we're being asked, how much did each eraser cost? Let's go take a look at the second problem. Maria bought 7 boxes. And then it says a week later, half all her boxes were destroyed in a fire. That's sad. And now there's only 22 boxes left. That means she had to have some more. She only bought 7. So somewhere she had a big old pile of boxes. And whatever she had, somewhere in there she bought 7 more, which means I got 7 more. But I had a bunch. In fact, I will just write, we had a bunch. A week later, half of them were destroyed. Half means divide by 2. So if I take the boxes she had plus 7 and I divide it by 2, and I'll tell you right here that when you don't know how many she started with this. Let's just call it X, because I don't know how many she started with, but I got to start somewhere. So that's what I started with. I started with X. I bought 7. Half of them were destroyed. And that left me with how many? If I had a bunch, bought 7, lost half of them, I have 22 boxes left. And that's how that problem is going to get set up. If you wanted to make it a little simpler looking, could be X plus 7 divided by 2 equals 22. That would work. You got to get rid of the 2 first. We got to use multiplying to get rid of the 2, and then we can get rid of the 7. Okay? Good luck. Let's try and set up a couple of these too, since these are a little bit more confusing. An ostrich is, whenever you see the word is, usually that's where your equal sign goes. So 108 inches tall. An ostrich that is 108 inches tall. Well, is equals. And then take a look, there's our equal sign. And what does it equal? 20 inches taller than 4 times the height of a kiwi. And the question is, what's the height of a kiwi? A kiwi's a little kiwi bird. And it says 20 inches taller, taller is plus, that's a more, than 4 times the height of a kiwi bird. Well, if I don't know how tall a kiwi bird is, let's call it a letter. It's going to be K. So K equals the height of a kiwi bird. And so 4 times the height of a kiwi bird is 4K. But then it says it's not just 4 times the height, it's 20 inches more than that. So plus 20. And that's the equation that you get to go out and solve. Let's take a look at number 6. An emu that measures 60 inches in height. Well, that's it, is that measures, that's its total. So an emu is this tall, but it says it's 70 inches less than 5 times the height of a cockapoo. I think that's what that is. 5 times the height of a cockapoo, let's call that K as well. So 70 inches less than 5 times, that means 5 times, but then 70 inches less than that. So we'll take away a 70. So 5 times the height of a cockapoo, but 70 inches less, that'll be the same as that 60-inch tall emu. That's how you set up those two equations. So there's a couple more problems left in this lesson. This one here just requires a little bit of vocabulary clarification. It says the average weight of the top 5 fish caught at a fishing tournament was 12.3 pounds. That's the average. So for this problem, the average is 12.3 pounds, because average just means if I add it all up, let's take a look at what that vocabulary word is. That means take these numbers, add them up, that's the sum, and then divide it by how many there are. In this case, it says there were 5 fish. So we're going to have to divide it by 5, and that equaled 12.3 pounds. So you can see that none of these fish actually weighed 12.3 pounds. And you can see that I have an empty box here. And when you have an empty box, that means I don't know what it is. I'm just going to call it X. But if I were to add up all these numbers, this right here requires you to do some calculator work. And you don't know what this is. So your total weight is going to be X plus whatever you get when you use a calculator to collect all these terms or combine those terms. And then you're going to divide it by 5 because we're going to get an average. And that average is going to be 12.3. And then you got to get X by itself. I need to know how big Wayne's fish was. And the way we're going to do that is we're going to multiply by 5 first. And that'll get rid of this 5. And then you're going to have to use the subtraction property to take this number away. And that'll tell you how big this is. Once you know X, then you'll be able to answer the question, what was the weight of the heaviest fish? Because right now, the heaviest fish is 12.8 pounds. But the question is Wayne's fish heavier or lighter than 12.8 pounds? So that's a problem that you need to solve.